As I explained in my first answer to the first question, the main ideas of the difference between the three notions of quantum. But now let's focus a little bit more on quantum cryptography versus post-quantum cryptography. Quantum cryptography relies heavily on hardware. So this is basically hardware solutions. There's quantum signaling happening between two parties if we're talking about quantum key distribution aspect. And what happens is that those two parties have to have those physical devices that are able to communicate using quantum principles and establish a key. And the security relies on the fact that if somebody tampers, means listens into their channel, that will be known. And so therefore that key will not be used. That's the major aspect of security there. So there's technically no mathematical aspect to this. It's just the hardware and physical properties of quantum communications. The other part of quantum cryptography is QRNG, so quantum random number bit generator. So today we're using PRNGs, pseudo-random number generators, but this is just basically a replacement. And technically, it's just another way to obtain randomness, which of course is also important. Also, we do have, I would say today's approach to random number generators, they're actually very high quality. Therefore, this notion is fixed and it's not really affected by quantum computing in a sense. Post-quantum cryptography, again, as I mentioned, is public key cryptography, or falls into the category of public key cryptography, and it basically changes the underlying hard mathematical problems from today's used mathematical problems. For example, RSA is based on factoring. Elliptic curve Diffie-Hellman is based on finding discrete logarithms in the elliptic curve group. All of these ones are vulnerable to quantum computing. Therefore, those problems need to be changed. So the fundamental underlying hard mathematical problems are replaced, but it's all still done classically. So you don't need a quantum computer or anything outside of what we have today to actually be able to use it. So therefore, and based on those hard mathematical problems, the algorithms for, again, key establishment for digital signatures are built. And that way, because those underlying hard mathematical problems are hard both for classical and quantum computer, they become safe. And this notion is called post-quantum cryptography. So again, cryptography that can be used today, could have been used yesterday, and can be used tomorrow.